Hello everyone, welcome to our first thesis presentation. Before I begin, I'd like to introduce the group. This is Ahmed Sultan, Salman Mahdi, Ali Sib, Yasser Sur, and myself, Karim Beoum. Before we delve into the presentation, I'd like to explain to you how we came up with our idea of rubberized concrete. In the beginning of last summer, we all got together as a group to decide on the concentration for which we wanted to decide our thesis. If it was either going to be on environment or construction materials or the structure. Having come together, we decided that what we feel most comfortable with and also what was most interesting to us was the construction materials concentration. And so we decided that if it was going to be this, then we had to make sure that we're going to be targeting both the environment, positively affecting the environment, whilst also contributing to construction materials and therefore the construction industry. After using all our time in research, compiling a lot of secondary research and information and our literature review, we were able to come up with the idea that we wanted to use rubber from waste tires and integrate it into the concrete to ensure to see its feasibility. Many of you may ask why we wanted to use the waste tire rubber. Well, we found out from our research, and you'll be seeing this later on through statistics from my colleague, that when waste tire, for example, when it's stockpiled in scrap yards, it has an exceptionally detrimental effect on the environment. And so we hope that by using the rubber and using it into the concrete, we will be able to lessen its effect. It has been said that also through our research that there are some benefits to using rubber in concrete. We of course cannot answer this question yet. However, through the coming tests that we will be running, we will hopefully be able to come up with some variable conclusions. I'll just take you very quickly through the outline. The background will just basically be some information on the statistics of waste tire and also its environmental effect in Egypt. The objective and scope is the direction of our thesis and also the feasibility of rubber in concrete itself. The approach and experimental work is just the series of steps that we will be running to be able to come up with the variable conclusions. The anticipated outcomes is what we feel we might be able to learn from what we will learn and achieve from having completed this project. The expected obstacles, hopefully we will be able to overcome them. And finally, the tentative timeline, which is what we will be doing and at what time over the course of this whole semester.
Okay. To begin with, construction engineers have been facing various problems in the construction engineering industry. Problems that lead us to solutions that take us nowhere. Solutions that in the end lead us to even more problems. Construction engineers have been running out of good quality coarse aggregates for various years. Or as we like to call them, virgin aggregates, which are aggregates that have yet to be contaminated by rubble and other quality increasing degree. We go to great lengths to obtain these kinds of aggregates, and it has a huge adverse effect on our environment. For various years, we have been killing wildlife, and not only that, but we've been also affecting the biodiversity of our environment by altering plants and also killing marine life. Moreover, it affects other ecosystems, adjacent ecosystems, by transferring dust, pollution, noise, and contaminating the water. We believe that the solution lies in that which we have an abundance of, being waste tires. We need to first define what waste tires are first. Waste tires are rubber tires that are no longer usable for their intended use. They are rendered obsolete. And environmentalists this has been a persistent problem for environmentalists because, unlike other materials, it's a non-biodegradable material, meaning that it isn't easily recycled as other materials, which is problematic because we have this habit in Egypt of, how do we eliminate or get rid of waste tires? We burn them, and that is a catastrophe because burning waste tires emits a toxic gas called carbon monoxide. Moreover, fun fact, it also affects our ecosystem and is an ecological problem because one waste tire can harbor over 4 million mosquito eggs. And as long as we're speaking statistics, it's important to point out that each year, Cairo alone, not Egypt, Cairo, produces over 9 million waste tires. And in the USA, over 44 million waste tires per year. So we could only imagine the amount of material that, if used correctly, can work in our advantage. That has given us great enthusiasm, especially in the civil engineering industry. We've seen in the civil engineering great success combining asphalt with rubber. So we hope, and we are very enthusiastic, that we can maintain and implement the same success with rubber and concrete, creating rubberized concrete. That way, we'll be killing two birds with one stone. Finally, creating a good material that can replace coarse aggregates and we'll be killing two birds with one stone. We'll be finally creating a good material to replace coarse aggregates, and we'll be doing the environment a favor. Finally, in a way, we'll be saving our environment. And that, ladies and gentlemen, is our objective for the next 13 weeks. And an idea which is simple in concept, it has the potential to revolutionize the industry. A method of construction without destruction. We aim to prove and to determine the feasibility and to what extent that rubber can partially replace coarse aggregates in our mixes to create a long and withstanding concrete material. And we've done our research. We've been through a rigorous literature review, and we believe that we can prove that in our next series of experiments.
Okay, our approach in experimental work consists of many things. First, we need to acquire consistent waste tires. Consistent meaning that they need to be consistent in their type and size and their type and size. And also we need to shred them, and then in some cases we need to treat the tires, the rubber, before putting them in the mix, and then we need to test our samples. As you can see in front of you, this is our experimental outline. Consists of 5 dosages, the first of which is a controlled mix, and the remaining 4 are rubber dosages that can be differentiated into different weights of the rubber chips in the mix itself. In rubber dosage number 3, we have treatment A and B, which are an additional treatments for the same dosage. These treatments we're going to discuss shortly. We're going to pick the 2 best fit that we see best fit that are going to yield for us better results for our tests. You may ask, why only rubber dosage number 2? Rubber dosage number 2 that has only treatments in it. Given the time constraint we have and the small schedule, we concluded that it's only feasible to only have treated rubber in only 1 dosage for our mixes. Okay. After acquiring the tires, we need to shred them into 2x2 or 3x3. It's still undecided, but that's not the problem now. The problem now is shredding the tires. We asked Dr. Salah Haggar, head of the mechanical engineering department in AC, and he referred us to that machine. That machine is called the Hungry Beast. It's a shredder. It's a thesis project by mechanical engineering students in spring 2012. We cut the tire in half in order for it to fit in the box, as you can see, and also to have a tip in it for the machine to suck it in. Fortunately, the attempt failed, and the machine doesn't have a big enough motor or big enough blades to cut the tires. So now we acquired 2 other sources that we contacted, and we're going to go visit them. One is in Ashar Ramadan, it's a factory, and the other one is in Alexandria, Borgulab.
Research has suggested that the surface of the rubber, the metal bonding that has to the surrounding matrix, and accordingly its high strength. Treatments may vary between plasma treatments, washing with water and acid etching, and various coupling agents. Through our literature review, we were able to write 6 different treatment methods, from which we'll be choosing only 2, according to the availability of the materials, our time constraint, and the effect they give to our addict. To start with washing our rubber chunks with water and carbon tetrachloride, this treatment enhances the bonding between the rubber aggregates and the surrounding matrix, and accordingly gives higher strength. Another one we're considering to use is washing water with washing our aggregates with water and the latex mixture cleaner, also called as latex tire added latex concrete, which increases the flexural strength of the concrete as well as increasing the impact resistance of it. And the latex admixture in general increases the water resistance as well as the conductive strength of the concrete. Another method we're also researching is soaking tires in acid and methylcellulose solution. This decreases the compaction of concrete due to the high viscosity of the solution, as well as soaking we are also considering to soak our aggregates in sodium hydroxide, which makes the surface rougher and enhances also the bonding for high compressive strength. There's another traditional method, or the most commonly used one, is coating the rubber aggregates with cement paste. This also enhances the bonding between the concrete for better adhesion and accordingly gives higher strength. Last but not least is adding ultrafine minerals such as zirca fume, which has two jobs. One, to reduce the size of the pores inside the rubber, as well as the homogeneity, which both increase the strength of our concrete. As for the test we'll be conducting, we'll be starting with the physical properties for the rubber, such as gradation for size control and absorption of the rubber. Fresh concrete testing will involve the slump, unit weight, and air content inside the concrete. We'll also be conducting the usual tests like compressive strength after 3, 7, 28, and 66 days. The flexural length with the deflection after 7 and 28 days. Another test we're conducting for our first time undergraduate students is the stress strain curve, which is conducted using the MTS, the Materials Testing System machine. It's founded in our labs at AUC. Another test we'll be conducting for our first time is the abrasion resistance test. To investigate the concrete's ability to resist friction. We'll also be conducting the chemical durability test, as well as the cracking assessment test to know its ability and durability. Another test we'll also be conducting for our first time is the shrinkage test, to check the concrete's shrinkage resistance. And as per Dr. Sharif's concern, we have decided to conduct the fire resistance test to ensure that the rubber embedded inside the concrete won't be flammable if the concrete is exposed to fire. We'll also have research, most research have showed us and suggested that the rubberized concrete has a special ability to resist the impact forces. Accordingly, we will be conducting the impact test with this machine also found at AUC in our lab. Last but not least, we are investigating and have asked and inquired about the thermal conductivity test. We have found it in Ma'had al-Tilmin in Haramain University, and due to the shortage of time of the semester, we'll be conducting it for one conventional sample and one of the dosages will be chosen.
Okay, so similar to other investigations, this one is likely to face some obstacles, such as ensuring a consistent supply of waste wires having similar properties throughout our experimental work, in addition to obtaining, shredding, and processing these waste wires before introducing them in the concrete mixtures. Also, we'll be having another challenge is to conduct new tests, as Salman mentioned, for the first time that we're not familiar with, along with the readiness of our lab and equipment. Also, we'll be having, after our extensive research, we predicted that some results will be shifted or have minor changes due to usage of rubber particles inside the concrete. So a possible adjustment will be needed. Finally, to be a huge obstacle for us is to complete our work within the time limit efficiently. And going for anticipated outcomes, they can be summarized in a better understanding of the waste material and its nature in Egypt, as well as exploring